Good day, everyone. Welcome to our class session. Today, we'll be exploring the fascinating world of natural resources and environmental management. This is part of our AGRI 224 course for the second semester of school year 2024-2025. On this first slide, you'll see the course title, the semester details, and the department and university information. I'll also introduce myself as your instructor, NP Maria Cristina C. La Casa from the College of Agriculture and Natural Sciences. Over the course of this presentation, we'll cover the principles and concepts of environmental science and ecology. So, let's get started and look forward to a meaningful and engaging discussion ahead. Welcome to our discussion on natural resources. Natural resources are the useful raw materials we obtain directly from the earth. They occur naturally, which means humans cannot create them. They exist on their own in nature. Instead, our role is to use and sometimes modify these resources in ways that benefit us. The materials used to make human-made objects are all considered natural resources because they originate from nature. When we talk about natural resources, we're referring to those resources that are found in their original, untouched form within the environment. They develop over many years without human intervention, taking a long time to form naturally. Mother Earth is rich with these natural resources, which develop using the surrounding environment. Some are essential for our survival, like water and air, which we cannot live without. Others, such as coal, gas, and oil, are primarily used to meet our daily needs and support our industries. Natural resources can be found in various forms: forests, mountains, minerals, coastal shores, wetlands, and each plays a vital role in sustaining life and human activity. Welcome to slide 3 of our presentation. Today, we'll explore the question, what is environment? The environment can be understood as all the external forces, influences, and conditions that impact the life, nature, behavior, growth, development, and maturity of living organisms. Think of it as everything outside an organism that can shape its existence. These external forces include a wide range of aspects: physical, intellectual, economic, political, cultural, social, and emotional. For example, physical factors like climate or terrain, economic conditions that influence resources, or social and cultural norms all play a role in shaping living beings. The natural environment itself is often divided into 4 main domains: lithosphere, atmosphere, biosphere, and hydrosphere. These domains represent the land, air, living organisms, and water, respectively. When we talk about the environment, it's usually understood as the surrounding conditions that directly affect organisms. But in a broader sense, it encompasses everything that influences an organism throughout its lifetime. So, in summary, the environment is the sum of all external factors impacting living things, and understanding these influences helps us better grasp how organisms grow and adapt within their surroundings. Welcome to this part of our presentation on environmental science. Environmental science, as we see here, is a dynamic and interdisciplinary field. It involves studying how living things and non-living parts of the environment interact with each other. A key focus is understanding the impact humans have on the environment. We look at the circumstances, objects, and conditions that surround organisms or communities, and explore the complex ways in which these elements interact. Wilson emphasizes that this field helps us grasp how different parts of our environment are interconnected. Inger and Smith highlight that environmental science isn't just about biology or chemistry alone. It combines scientific insights with social understanding. This means we consider not only the natural processes, but also how human actions influence the environment and what that means for society. So, in essence, environmental science helps us understand the delicate balance of our planet and our role within it. It's about seeing the bigger picture and recognizing our responsibility to protect and sustain the environment for future generations. Today, I want to talk about environmental management, a concept that goes beyond just managing natural resources. It's about considering not only the environment itself, but also the social and political contexts that influence it. As R. Clark from Birkbeck College emphasizes, environmental management involves questions of value and how resources are distributed. It also looks at regulatory mechanisms and strives for fairness across interpersonal, geographic, and intergenerational lines. Essentially, it's about making sure our policies and strategies are environmentally sound and equitable for everyone. This approach acts as a bridge between scientific research and policymaking, helping us develop sustainable development strategies that are practical and effective, as S. MacGill from Leeds University points out. At its core, environmental management involves allocating both natural and artificial resources in the best way possible. The goal is to maximize the environment's capacity to meet human needs, ideally on a sustainable basis. This means using resources wisely, ensuring that our development today doesn't compromise the needs of future generations, and always aiming for the most efficient and fair use of our environment. Welcome to Slide 6. Today, we're focusing on environmental management within the context of Agri 224 at ESSU, Salcedo. So, what does environmental management really mean? Well, at its core, it's about finding the best possible environmental option that promotes sustainable development. This idea isn't new. It's been a key part of sustainable development concepts since the 1990s. When we talk about the best possible environmental option, or BPEO, we're referring to the most effective approach that balances environmental benefits with practicality. Usually, this involves using the best available techniques that don't entail excessive costs, which is often summarized by the acronym BATNEC, Best Available Techniques Not Entailing Excessive Costs. In essence, environmental management is about controlling all human activities that significantly impact our environment. Whether it's agriculture, industry, or other sectors, the goal is to manage these activities to minimize harm and enhance sustainability. And it's not just about controlling. It's also about managing the overall environmental performance of organizations, bodies, and companies. As Sherratt pointed out in 1995, this means actively overseeing how organizations impact the environment and striving for continuous improvement. So, to connect all these points, environmental management involves making informed, practical decisions to protect our environment while allowing human activities to continue sustainably. It's a crucial part of our overall effort to promote responsible development. Today, I will discuss the key concepts related to environmental management, as outlined in Slide 7. First, let's understand that environmental management is essentially a decision-making process. Its main goal is to regulate how human activities impact the environment, ensuring that these activities do not impair the environment's capacity to support human development. This idea is rooted in the concept of green development from the 1990s, emphasizing sustainable use of resources. Now, it's important to recognize that environmental management doesn't mean mastering every single environmental issue or component. Instead, the focus is on studying and controlling processes to achieve specific objectives. As Royston pointed out in 1978, the role of an environmental manager is to analyze these processes and guide them toward desired outcomes, rather than trying to fix everything at once. Furthermore, environmental management is a broad, interdisciplinary field. It involves professionals from diverse backgrounds, natural sciences, social sciences, engineering, law, and design, working together. These experts approach problems from a quantitative or futuristic perspective, aiming to find practical solutions for the human-altered environment. So, in summary, environmental management is about making informed decisions to balance human needs with environmental sustainability, using a collaborative, interdisciplinary approach to control and influence environmental processes effectively. Welcome to Slide 8. Today, we'll explore the concept of natural resource management, which refers to the sustainable use of our major natural resources. These include land, water, air, minerals, forests, fisheries, and even wild flora and fauna. You see, all of these resources work together to provide ecosystem services that significantly improve our quality of life. As Muralikrishna and Manikam highlight, managing these resources sustainably is crucial for our well-being. Next, we'll look into what we call integrated natural resource management. This is a deliberate process where we incorporate various aspects of resource use into a cohesive system. The goal here is sustainability, meeting the needs of farmers and other users, like ensuring profitability and reducing risks, while also considering the broader community's well-being. Think of it as managing resources in a way that balances different needs and goals, ensuring that we can continue to benefit from them now and in the future. This approach aligns with our overall theme of sustainable development, emphasizing that responsible management benefits everyone, from individual farmers to entire communities. Let's talk about watershed management. Essentially, it's about organizing and guiding how we use land, water, and other natural resources within a watershed. The goal is to make sure we get the right goods and services from these resources, all while reducing negative impacts on the soil and the watershed itself. This process isn't just about the environment. It also involves socioeconomic factors, human institutions, and the physical relationships between soil, water, and land use. It's like a web of interconnected elements that need to work together smoothly. An important part of watershed management is understanding how upland areas, those higher elevations, are connected to downstream areas where water and resources flow. This connection means that what we do upstream can significantly affect downstream communities and ecosystems. By grasping these key points, we can better appreciate how integrated watershed management is crucial for sustainable development and environmental health. All right, let's talk about integrated natural resource management. Essentially, it's an approach that's adaptive and comprehensive, meaning it constantly evolves based on new information and conditions. It involves planning that looks at multiple resources at once, like land, water, plants, animals, and even human activities, so we can manage them in a balanced way. The goal here is to maintain healthy ecological systems, support economic needs, and respect cultural and social values, all within a specific watershed area. When we say watershed, think of it as the land area that drains into a particular body of water, like a river or a lake. This management process recognizes that water isn't just surface water flowing in streams. It also includes groundwater, which is the water stored underground. Both need to be considered because they interact closely. Importantly, this approach emphasizes understanding how water, plants, animals, and human land use are interconnected within these boundaries. For example, how farming activities affect water quality, or how urban development influences natural habitats. The key is to plan in a way that respects these interactions, ensuring that all resources are managed sustainably for future generations. This concept, as outlined by the Red Deer River Watershed Alliance in 2015, highlights the importance of thinking holistically about our environment and resources, integrating planning across different sectors and scales to create resilient and healthy ecosystems. Today, I want to talk about integrated watershed management, which is a comprehensive approach that emphasizes looking beyond just the hydrology of a watershed. Instead, it encourages us to consider multiple uses of watershed resources, balancing human needs with environmental sustainability. The goal is to protect ecosystem services and preserve biodiversity, ensuring that we manage our watersheds responsibly for both people and nature. Moving on, I'll discuss community-based natural resource management, or NRM. This approach recognizes the vital role of local communities in managing their resources. It leverages traditional knowledge, which has been developed over generations, and aligns conservation efforts with the needs and aspirations of the community itself. This method is more sustainable and equitable compared to traditional fortress conservation, where communities are often excluded from protected areas and don't benefit from conservation initiatives. Instead, Community-based NRM promotes participation and shared benefits, making conservation efforts more effective and just for everyone involved. By integrating these approaches, we can create a more balanced and inclusive way of managing our watersheds and natural resources, fostering a sustainable future for both communities and ecosystems. Water resources are essentially sources of water that are useful or could potentially be useful to us. When we talk about uses of water, we're referring to a wide range of activities, including agriculture, industry, household needs, recreation, and even environmental functions. It's important to remember that most of these human uses rely on fresh water, which is a finite and vital resource. Understanding how these water sources are utilized helps us appreciate their value and the need for sustainable management. This ties into the overall theme of our presentation, which emphasizes the importance of conserving our natural resources for future generations. Air is a truly wonderful and precious natural resource, and it's a gift from the Almighty. It might seem simple, but it's actually essential for all life on Earth. It's the main natural source that supports the survival of plants, animals, and us humans. The Earth's atmosphere is made up of different gases, like oxygen and nitrogen, that keep everything alive and thriving. Without air, life as we know it wouldn't be possible. This highlights how important non-living resources are, resources that aren't alive, but are vital for sustaining life. Understanding and protecting these resources is key to maintaining the balance of our environment and ensuring a sustainable future. Soil is incredibly vital because it provides much of the food we consume daily. It's the foundation that supports the growth of agricultural crops, ensuring we have enough to eat. But soil's importance doesn't stop there. It also plays a crucial role in maintaining both natural and artificial vegetation, helping forests, parks, and landscaped areas thrive. Additionally, soil is essential for supporting the foundations of buildings, roads, and communication infrastructures. Without healthy, stable soil, these structures wouldn't stand the test of time. As we continue to explore non-living resources, it's clear that soil is a fundamental element that underpins much of our daily lives and development. Groundwater is essentially rainwater that has made its way through the soil and reached underground aquifers. These aquifers are like natural reservoirs that store water beneath the Earth's surface. Now, this fresh groundwater is incredibly important because it serves many vital purposes. The largest use of this groundwater is for irrigating crops, which supports agriculture and helps feed populations. But it's not just for farming. People also extract groundwater for everyday needs, such as drinking, cleaning, bathing, and cooking. It's a crucial resource that sustains both our daily lives and our food production. Understanding how groundwater moves and how we use it is key to managing our natural resources responsibly. It ties directly into our broader discussion on how natural resources support our basic needs, highlighting the importance of conserving and protecting these vital supplies. Coal is a vital resource that plays a significant role in our daily lives. It is primarily used to generate heat, energy, and electricity. Humans have found many ways to utilize coal, not only as a fuel but also as a source of carbon for various applications. As a solid fuel, coal is burned to produce heat, which can be used in stoves, furnaces, and boilers. This heat is essential for cooking, heating buildings, and industrial processes. Additionally, coal powers many electrical generating plants, providing a substantial portion of the electricity we rely on every day. Understanding how we harness coal's energy helps us appreciate its importance in meeting our basic needs, and supports the broader theme of natural resources being fundamental to our daily lives. Oil has been used in one form or another for thousands of years, but it really became a crucial part of our economy only in the last 2 centuries. It's fascinating to see how this resource has transformed our daily lives. Oil powers our industries, helping produce a wide range of goods we rely on every day. It also heats our buildings, keeping us warm during colder months. But perhaps most importantly, oil is the raw material for many products like plastics, paints, and textiles that are essential in modern life. However, when we think about its importance, especially in the context of transportation. That's where oil becomes truly indispensable. Without oil, the transportation systems that connect us and keep economies moving would face enormous challenges. So, understanding the role of oil really helps us see how vital natural resources are for meeting our basic needs and supporting our way of life. Natural gas is a type of fossil fuel that plays a significant role in our daily lives. It's commonly used as a source of energy for heating our homes, cooking our meals, and generating electricity that powers our homes and businesses. But its uses don't stop there. It's also a key fuel for vehicles, especially in some regions where natural gas is an alternative to gasoline or diesel. Additionally, natural gas serves as a vital chemical feedstock in the manufacturing industry. It's used to produce plastics and a variety of other important organic chemicals that are essential in many products we rely on. Understanding the role of natural gas helps us see how interconnected our energy needs are with the broader chemical and manufacturing industries. It's a great example of how natural resources support our basic needs, as we've been discussing throughout this presentation. As the world continues to modernize and our populations grow, we see a rising demand for housing and construction projects. This often leads to the reduction of open green spaces, which is a concern because forests are essential for maintaining the overall health of our planet. They support the ecology by providing vital natural resources and sustaining life. Forests are especially important because they help purify the air we breathe and provide the lumber needed for building our homes and infrastructure. So, as we develop, it's crucial to remember the importance of preserving these natural forests to ensure a balanced environment and sustainable growth. Iron is also in limited supply, which makes it a precious resource. It's primarily made from elements like silica, which need to be heated extensively to produce pig iron. This process is crucial because pig iron serves as the foundation for many industrial materials. During ancient times, iron was the most important natural resource on Earth. It revolutionized the way people built weapons, allowing for stronger, more durable tools and armaments. It also enabled better transportation and taller, more resilient buildings. Today, both iron and steel continue to be fundamental in modern industries, supporting infrastructure, manufacturing, and technology. So, understanding the availability and importance of iron helps us see how natural resources have driven progress from ancient civilizations to today's advanced societies. Phosphorus is a vital nutrient that comes from phosphate rock, and it plays a crucial role in growing all of our food and crops. Without it, our agricultural systems wouldn't be able to produce the yields we depend on. However, one of the key issues is that phosphate rock isn't evenly distributed around the world. In fact, it's only found significantly in just 3 places: the United States, China, and Morocco. This limited geographic availability makes it a critical resource for global food security. Currently, the known reserves of phosphate rock are projected to last about 100 more years at our current rate of use. That might sound like a long time, but when you consider the growing global population and increasing food demands, it raises concerns about sustainability. What's more, there's been little investment or research into developing new, safe fertilizers that could effectively replace phosphorus. This gap in innovation means we're heavily reliant on these limited resources, which could pose risks for future food production. Connecting this to our overall theme, it highlights the importance of sustainable resource management and the need for innovation in agriculture. We need to think proactively about how to extend these resources and develop alternatives to ensure food security for generations to come. Red phosphorus is actually used in match heads, which might surprise some of you. When you think about it, a match is a simple but essential tool for starting a fire, and the red phosphorus plays a crucial role in making that happen. It's interesting how such a small component can have such a big impact on our daily lives, especially in terms of basic needs like warmth, cooking, and safety. This highlights how natural resources, even something as seemingly simple as phosphorus, are vital in providing us with the tools we need. It also connects to our overall theme of understanding how natural resources are fundamental for our everyday existence. Fertilizer plays a crucial role in agriculture, and one of its key components is phosphorus. Phosphorus is well known for being essential to DNA, the building block of life, which highlights its importance at a biological level. But beyond that, phosphorus is also vital in fertilizers because it promotes healthy root development and overall plant growth. Without enough phosphorus, plants can struggle to grow properly, which can impact food production and crop yields. So, understanding the role of phosphorus helps us appreciate how natural resources like fertilizers support our basic needs, ensuring we have enough food and healthy ecosystems. This connection underscores the importance of managing our natural resources wisely to sustain agriculture and meet future demands. Solar energy plays a fundamental role in almost every life process, if not all of them. Both plants and animals rely on solar energy to create essential nutrients within their cells. For example, plants use sunlight to produce chlorophyll, which is vital for their survival. Humans, on the other hand, harness the sun's rays to generate vitamin D, which is crucial for our health. But what's really interesting is that when humans learned to convert solar energy into usable forms, it transformed its importance even further. It became a powerful resource that could be harnessed for various needs beyond just biological processes. This understanding underscores why renewable energy sources like solar power are so vital in our pursuit of sustainable development and energy independence. Wind power is the use of air flow through wind turbines to mechanically power generators for electricity. Essentially, when the wind blows, it turns the blades of these turbines, which then generate electrical energy. This process makes wind power a very promising renewable energy source. Compared to burning fossil fuels, wind power is plentiful and widely available in many parts of the world. It's a clean energy source, meaning it doesn't produce greenhouse gases during operation, which is a huge advantage for combating climate change. Additionally, wind power consumes no water, unlike some other energy sources, and it uses very little land, making it quite efficient. The overall environmental impact of wind energy is much less problematic than traditional non-renewable power sources. This highlights how wind power aligns with our overall goal of shifting toward cleaner, more sustainable energy options. Hydropower, or hydroelectric power, is fueled by water, which makes it a very clean fuel source. Because it doesn't produce air pollution like traditional power plants that burn fossil fuels such as coal or natural gas, it's much better for our environment. This means that hydroelectric energy helps reduce air pollution and greenhouse gases. Another important point is that hydroelectric power is a domestic source of energy. That means each state can generate its own energy locally, rather than relying on imported fuels from other countries. This enhances energy independence and security for our nation. Overall, hydropower is a sustainable, environmentally friendly, and locally available energy option that aligns with our goal of increasing renewable energy resources. It plays a key role in creating a cleaner, more resilient energy future for all of us. Biomass is a biological material that serves as an important energy source for humans. It's made up of a mixture of organic molecules, including carbon, hydrogen, oxygen, nitrogen, and alkaline earth metals. What's really interesting about biomass is that it's a renewable energy source, meaning it can be replenished naturally over time. This makes it a sustainable option compared to fossil fuels. Using biomass as an energy source also helps reduce carbon emissions, which is a big plus for protecting our environment. It's versatile too. Biomass can be used to produce steam and electricity, which are essential for our daily energy needs. Plus, it can even fuel vehicles, providing a renewable alternative to traditional fuels. Overall, biomass plays a crucial role in our shift towards more sustainable and environmentally friendly energy resources. It's a key piece in the puzzle of reducing our carbon footprint and moving towards a greener future. Wood has been humanity's very first source of energy, and surprisingly, it still holds a significant place today. In fact, it remains the most important single source of renewable energy worldwide, providing over 9% of the total primary energy supply across the globe. Now, technically speaking, wood is considered a renewable resource because it's a form of biomass. And all biomass, in general, is traditionally seen as renewable because it's part of the natural carbon cycle on Earth. Essentially, as trees grow, they absorb carbon dioxide, and when we use wood for energy, that carbon is released back into the atmosphere, completing the cycle. This connection to the natural carbon cycle is what makes biomass, including wood, a renewable energy source, at least in theory. So, understanding this helps us see how renewable resources like wood play a crucial role in our overall energy landscape, especially as we look for sustainable solutions. Fossil fuels are a type of non-renewable energy source, which means they can't be replenished within a human lifetime. They actually formed over 300 million years ago, long before our time. These fuels are made up of the remains of ancient plants and animals that lived millions of years ago. When these organisms died, their bodies didn't decompose completely. Instead, they were buried under layers of earth, which protected them from decay. Over vast periods of time, heat and pressure transformed these buried organic materials into the fossil fuels we use today. There are three main types of fossil fuels: oil, natural gas, and coal. Each of these plays a significant role in our energy consumption, but they also come with environmental concerns. Understanding the origins of these fuels helps us see why they are finite resources and why there's a growing need to explore renewable alternatives. This connection is essential as we consider sustainable energy solutions for the future. Let's talk about the islands of the Philippines. The country is made up of more than 7,100 islands, which is quite remarkable. Because of this, it's actually the third largest English-speaking country in the world. This vast archipelago is situated in the South China Sea, serving as a key crossroads of the Orient, connecting various regions and cultures. The Philippines is famous for its beautiful tourism spots. Think stunning beaches, vibrant festivals, and rich cultural heritage. Its diverse culture has been shaped over centuries, influenced by the occupation of different nations, which adds to its unique identity. But beyond its cultural and touristic appeal, the Philippines is also rich in natural resources. These resources are vital because they help sustain the nation's economy and contribute significantly to its regional importance. So, the country's natural wealth is a key factor in its development and growth, making it a fascinating blend of natural beauty, cultural diversity, and economic significance. Oceans. Being surrounded by the ocean, it is no surprise that the Philippines relies heavily on its waters as a vital natural resource. The country has more than 640,000 square miles of territorial waters, which is quite significant. Within these waters, there's an incredible abundance of marine life and materials that are not only valuable to our people, but also to the global community. Out of roughly 2,400 marine species found in Filipino waters, at least 65 have solid commercial value, meaning they are actively harvested and sold. These include crabs, seaweed, pearls, and other ocean treasures. This highlights how our seas are among the top resources for our archipelago, providing livelihoods, food, and economic opportunities. So, as we see, the ocean is truly a cornerstone of our natural resources and plays a crucial role in our country's development and sustainability. Today, I want to talk about the major crops of the Philippines and how our country's unique volcanic history and expansive plains contribute to our agricultural strength. The volcanic activity over the centuries has created very fertile soil, especially in regions like central Luzon, Cagayan Valley, and Negros. These areas are known for their rich land, which is vital for farming and supporting the livelihoods of many Filipinos. Our primary crops include rice, corn, sugarcane, abaca, and tobacco. Rice and corn are mainly used for local consumption, feeding our population and supporting our daily needs. On the other hand, sugarcane, abaca, and tobacco are significant for export, helping boost our economy. This combination of fertile land and diverse crops highlights how agriculture remains a cornerstone of our nation's livelihood and economic development. It also connects to our overall theme of natural resources shaping our country's growth and sustainability. Let's talk about the minerals found in our country. Our mineral deposits can be broadly classified into two categories: metals and nonmetals. When we look at the estimates, the metal deposits are around 21.5 billion metric tons, which is quite significant. Non-metal deposits, on the other hand, are projected at about 19.3 billion metric tons. Now, among the metals, nickel stands out as the largest deposit in terms of both quantity and size. You'll find nickel primarily in Surigao del Norte, Davao, Palawan, Romblon, and Samar. Iron deposits are found in Ilocos Norte, Nueva Ecija, Camarines Norte, and Cotabato. For copper, the key areas include Zambales, Batangas, Mindoro, Panay, and Negros. Switching over to nonmetals, the most abundant ones are cement, lime, and marble. But there's also a variety of other nonmetal minerals like asbestos, clay, guano, asphalt, feldspar, sulfur, talc, silicon, phosphate, and marble. These resources are vital for many industries and really highlight the diversity of our country's natural wealth. Understanding these deposits is crucial because they play a significant role in our economic development and industrial growth. So, recognizing where these resources are located helps us appreciate the richness of our natural resources and their potential for future utilization. Let's talk about flora. The tropical climate in the Philippines truly makes it an ideal location for a wide variety of flowers and plants. Because of these favorable conditions, the islands are home to more than 2 million species of plants. That's a staggering number, highlighting just how rich and diverse the plant life is here. Interestingly, several of these species are found nowhere else on the planet, making the Philippines a crucial area for plant conservation and biodiversity. However, it's important to note that much of this flora has been diminished due to overharvesting. Despite this challenge, many of these plants are still vital as natural resources. They are used as ingredients in various products that we export commercially, which shows how deeply intertwined they are with the country's economy. This connection between natural resources and economic development is a key theme in understanding how the Philippines manages its rich biodiversity. It also underscores the importance of sustainable practices to preserve these unique plant species for future generations. Fishery resources are a vital part of the Philippines' natural wealth. With its territorial waters stretching up to 1.67 million square kilometers, the country is truly situated in a global fishing hub. This extensive area supports a diverse range of marine life, including around 2,400 fish species. Out of these, about 65 species are particularly valuable for commercial purposes, contributing significantly to local livelihoods and the economy. But it's not just fish that our waters offer. We also have rich marine products like corals, which are essential for the jewelry and aquarium industries, pearls, which are prized worldwide, crabs, a popular seafood, and seaweeds, which have various uses in food, cosmetics, and even agriculture. Some of the Philippines' top saltwater fishing areas are well known internationally. For example, Sintenki Island in Sulu, Estancia in Bohol, Malampaya in Palawan, Lingayen Gulf in Pangasinan, and San Miguel Lake in Camarines Norte. Additionally, Bantian Channel in Cebu and the seas of Quezon and Sorsogon are also renowned for their excellent fishing grounds. All of these resources highlight how crucial our marine environment is, not just for sustaining our fisheries, but also for supporting our economy and the livelihoods of many Filipinos. This interconnectedness of our natural resources underscores the importance of sustainable management as we continue to benefit from the richness of our waters. Our forests are a vital part of the Philippines' natural landscape. The country boasts extensive tracts of lush, green forests that are not only beautiful, but also incredibly important for biodiversity and environmental health. In fact, nearly half of the total land area of the Philippines is covered by forests, which shows just how rich and widespread these ecosystems are. A particularly interesting point is that about 60% of these forests are located in Mindanao. This highlights Mindanao's significance as a major forested region in the country, contributing greatly to the overall natural resources. Understanding the distribution and extent of our forests helps us appreciate the importance of conserving these natural resources. They provide us with essential services like clean air, water filtration, and habitat for countless species. So, as we continue to explore our natural resources, keep in mind that our forests are a key component, not just in terms of land cover, but also for the ecological balance and sustainability of the Philippines as a whole. Let's talk about deforestation. When we cut down trees, it's often to obtain timber for making furniture and paper products. While these materials are useful, the way we harvest them can have significant impacts. For example, some practices leave the forest floor bare, which means there's less protection for the soil. This can lead to soil erosion, and one serious consequence of that is an increased risk of flooding. Without the trees and ground cover to absorb rainfall, water runs off more quickly. Additionally, it's important to remember that many living organisms depend on forests for their habitat. When we remove trees, we're not just losing wood, we're also disrupting entire ecosystems. This highlights how human activities like deforestation can have far-reaching effects on natural resources and biodiversity. All right, let's talk about overfishing. This occurs when animals from the marine environment are hunted excessively, not just by humans, but also by other animals. When this happens, it can cause a significant reduction in the number of marine animals, which disrupts the balance of the ecosystem. Human activities, such as commercial fishing, play a big role here, and they often lead to pollution of marine waters. This pollution can come from discarded fishing gear, oil spills, or chemicals, all of which harm marine life. Additionally, overfishing can destroy habitats like coral reefs and seafloor environments that are crucial for the survival of many marine species. So, it's important to recognize how these activities impact not only the animals, but also the health of our entire ocean system, connecting directly to our overall theme of how human actions influence natural resources. Water pollution is a serious issue, and one of the key factors contributing to it is the excess of nutrients in water bodies. When too many nutrients, like nitrogen and phosphorus, enter the water, they can cause rapid overgrowth of bacteria and algae. This overgrowth is problematic because it consumes oxygen in the water, which is essential for the survival of many aquatic species. So essentially, these nutrients can create dead zones where life struggles to thrive. What's even more concerning is that these nutrients don't stay put. They get transported downstream, moving through streams, rivers, and eventually reaching bays and other larger water bodies. This means that pollution introduced far upstream can still impact water quality far away, in places that might seem unaffected at first glance. This highlights how human activities, especially those involving agriculture and waste management, can have far-reaching effects on water quality. It's a reminder that protecting water resources requires us to manage nutrient runoff carefully, not just locally, but across entire watersheds. Water pollution is a serious issue, and one of the key factors contributing to it is the presence of excess nutrients in our water bodies. When there are too many nutrients, it can lead to rapid overgrowth of bacteria and algae. This overgrowth is problematic because these organisms consume a lot of oxygen, which is essential for other aquatic species to survive. So, essentially, the more algae and bacteria grow, the less oxygen is available for fish and other aquatic life, creating a dangerous imbalance. What's even more concerning is that these nutrients don't stay put. They can be transported downstream. This means that nutrient pollution originating in one area can end up affecting streams, rivers, and bays far away from the original source. This interconnectedness shows how human activities upstream can have far-reaching impacts on water quality downstream. Overall, this highlights how human actions can significantly impact water resources, not just locally, but across entire watersheds. Managing nutrient runoff is crucial for protecting water quality and maintaining healthy aquatic ecosystems. When we talk about air pollution, the main thing to remember is that most of it comes from human activities. For instance, When we burn fossil fuels in motor vehicles, factories, and power plants, these sources release large amounts of pollutants into the atmosphere. These include gases like carbon monoxide, ozone, and nitrous oxides, which can be harmful to both the environment and our health. Additionally, there are pollutants like lead-based compounds, which are particularly dangerous because they can cause serious health issues such as cancer, reproductive problems, and birth defects. This highlights how human actions, especially those related to energy consumption and industrial processes, significantly impact air quality. Understanding this connection is crucial because it ties directly into our broader discussion on how human activities affect natural resources. It's a reminder that our daily choices and industrial practices have real consequences for environmental health and human well-being. As the human population continues to grow, we're using natural resources much faster than before. Now, some of these resources are renewable, meaning they can be replenished naturally over time. But here's the catch. When we use them too quickly, they can't regenerate fast enough to keep up with our demand. This puts a lot of pressure on these resources and can lead to shortages. On the other hand, non-renewable resources, things like fossil fuels and minerals, are limited by nature. Once we use them up, they're gone forever. When we consume these resources at an accelerated rate, we're rushing towards their depletion much sooner than expected. This entire situation highlights how human activities are impacting our natural resources. It's crucial to understand that our consumption habits directly affect the availability of these resources for future generations. Climate change is largely driven by human activities, especially the emissions of carbon dioxide and other greenhouse gases. These activities have caused the global temperature to rise, and this warming has significant impacts. For example, it changes where crops can be grown effectively, which affects food production. It also influences the habitats of certain fish and animals, potentially disrupting ecosystems that are vital for biodiversity and human livelihoods. Moreover, the increase in temperature is causing glaciers to melt at an accelerated pace. When glaciers melt, they release large amounts of water into the oceans, leading to rising sea levels. This rise in sea level is a serious threat to coastal communities and economies that depend heavily on coastal resources. As we can see, human activities are directly impacting natural resources in ways that can threaten both environmental stability and human well-being. This connection underscores the importance of addressing climate change as part of our broader efforts to protect natural resources and ensure sustainable development. Reforestation is a crucial concept to keep in mind as we think about protecting our environment. Instead of focusing only on deforestation, we should emphasize reforestation, planting new trees to restore natural habitats. It's important that we seek help from the government to support plantation programs, as these initiatives can make a significant impact. But remember, reforestation isn't just about planting trees, it's about ensuring they grow and thrive. Everyone has a role to play in this effort, participating in planting activities and caring for the plants afterward. When we all get involved, we contribute to a healthier, more sustainable environment for ourselves and future generations. Proper waste disposal is essential for maintaining a healthy environment. We should develop the habit of disposing of our waste properly, making it a routine part of our daily lives. By doing so, we not only keep our surroundings clean, but also help restore and preserve biodiversity. When waste is managed correctly, it reduces pollution and protects the habitats of many species. This practice is a simple yet powerful way to support the overall conservation of natural resources. Remember, small, consistent actions can lead to big positive impacts on our environment and future generations. Today, I want to emphasize the importance of teaching farmers about mixed cropping, crop rotation, and the proper use of fertilizers, insecticides, and pesticides. These practices are essential in promoting sustainable farming and conserving our natural resources. By encouraging farmers to incorporate manures, biofertilizers, and organic fertilizers, we can enhance soil health and reduce dependence on chemical inputs. These methods not only improve crop productivity, but also help protect our environment. Remember, sustainable agriculture is about working with nature, and education is key in ensuring farmers adopt these beneficial practices. Today, I want to talk about wildlife conservation. We all agree that protecting wildlife is essential for maintaining the balance of our ecosystems. Even though hunting is officially not allowed, unfortunately, some individuals still engage in it illegally. This is a serious issue that threatens many species. That's why it's important for us, especially educated young people, to learn and understand the significance of the Wildlife Act. We should be the ones to teach others about respecting these laws and the importance of conserving our natural resources. By doing so, we contribute to the overall goal of preserving biodiversity and ensuring that future generations can enjoy the richness of our wildlife. Remember, conservation isn't just about protecting animals, it's about safeguarding the health of our entire planet. Let's talk about the importance of saving energy. We really need to focus on developing effective energy-saving methods because, ultimately, this helps us prevent unnecessary wastage. Remember, every bit of energy we save is essentially energy that we don't need to produce in the first place. It's a simple but powerful concept. Energy saved is energy produced. By being mindful of our energy consumption, we contribute to conserving natural resources and protecting our environment. This idea ties directly into our overall goal of responsible resource management, which is essential for sustainable development. So, let's stay committed to using energy wisely and efficiently. All right, now let's talk about some practical ways to improve our irrigation efficiency and really make a difference in conserving water resources. One effective method is using drip irrigation, which delivers water directly to the roots of plants through a network of tubes and emitters. This targeted approach minimizes water waste and reduces evaporation. Similarly, sprinkling irrigation mimics natural rainfall, but by controlling the amount and timing of water application, we can significantly cut down on unnecessary water loss. Both methods are valuable tools in our effort to conserve natural resources. By adopting these techniques, we not only boost crop productivity, but also contribute to sustainable water management, which is a crucial theme in our overall discussion on resource conservation. Today, I want to emphasize the importance of recycling waste and wastewater for agricultural purposes. By doing so, we can effectively conserve our natural resources while also supporting sustainable farming practices. Reusing waste products not only reduces environmental pollution, but also provides a valuable source of nutrients for crops. Wastewater, when properly treated, can be a reliable water source, especially in areas facing water scarcity. This approach aligns perfectly with our overall goal of conserving natural resources and promoting responsible environmental stewardship. Ultimately, recycling waste and wastewater is a practical and impactful way to ensure a healthier planet and a more sustainable future for agriculture. Since some resources like coal and natural gas are limited, we need to focus on making use of renewable resources for our power generation and other energy needs. These renewable sources, such as solar, wind, and hydro, are sustainable and can provide us with a steady supply of energy without depleting natural reserves. It's also important to recognize that our energy requirements are inevitable. We cannot do away with energy altogether. So, the challenge is to find suitable substitutes for these finite resources, alternatives that are eco-friendly and efficient. By shifting to renewable energy, we not only meet our energy demands, but also help conserve our natural environment. This approach aligns with the overall goal of conserving natural resources and ensuring a sustainable future for the next generations. So, embracing renewable energy isn't just a choice. It's an essential step toward responsible resource management. Today, I want to highlight an important step we can take to conserve our natural resources: installing rainwater harvesting systems in houses and colonies. By setting up these systems, we can efficiently collect and store rainwater for various uses, reducing our reliance on traditional water sources. This simple yet effective practice helps us manage water more sustainably and protects our environment. As part of our broader goal of conserving natural resources, implementing rainwater harvesting plays a crucial role in creating resilient communities. It's a practical solution that benefits both our ecosystems and our daily lives, making water availability more reliable while preserving our precious natural resources for future generations. Today, I want to emphasize the importance of educating local communities about the protection and wise use of our natural resources. It's crucial that we empower people with the knowledge they need to conserve the environment around them. When communities understand how to sustainably manage resources like water, forests, and soil, they can help preserve these vital assets for future generations. This education not only promotes environmental stewardship, but also supports the overall well-being and resilience of the community. Remember, conservation is a shared responsibility, and by working together, we can make a significant impact. This approach aligns closely with our broader goal of sustainable development and environmental preservation. So, let's focus on spreading awareness and encouraging responsible use at the local level, because every small effort counts in protecting our natural resources. Earth provides enough to satisfy every man's needs, but not every man's greed. What Mahatma Gandhi is reminding us here is that our planet has ample resources to meet our basic needs, things like food, water, shelter, and energy. However, the problem arises when greed drives us to overconsume or waste these resources, exceeding what is necessary. This quote highlights the importance of contentment and sustainability. It ties directly into our overall theme of responsible stewardship of the environment. If we can learn to live within our means and respect the limits of our planet, we can help ensure that resources are available not just for us, but for future generations as well. So, the key takeaway is that fulfilling our needs is entirely possible without harming the Earth. It's our greed that threatens that balance. Let's take a closer look at Section 1.2, Ecological Principles and Concepts. Here, we're diving into the fundamental ideas that help us understand how ecosystems function and how living organisms interact with their environment. These principles are the building blocks for understanding the complex web of life around us. One key concept is the idea of energy flow, which explains how energy moves through different levels of an ecosystem, from producers to consumers and decomposers. Recognizing this helps us see how each species plays a role in maintaining a balanced system. Another important principle is nutrient cycling, which highlights how essential elements like carbon, nitrogen, and phosphorus are recycled within ecosystems. This natural process sustains life and keeps ecosystems productive over time. We also need to consider the concept of biodiversity, which refers to the variety of life within an ecosystem. Greater biodiversity often means greater resilience, allowing ecosystems to better withstand changes and disturbances. Connecting these ideas to our overall theme, understanding ecological principles helps us appreciate the delicate balance of nature and the importance of sustainable practices. By grasping these concepts, we can better develop strategies to protect and preserve our environment for future generations. Today, we're going to explore the fascinating study of how organisms interact with their environment. All living things, or organisms, must engage with both the living and non-living elements around them. This interaction is what we call ecology. Essentially, ecology is the study of these relationships and how they influence the survival and functioning of organisms. By understanding these connections, we gain a better picture of the complex web of life on Earth. Remember, every organism is part of a larger system where they depend on and influence their surroundings. This idea ties directly into our overall theme of understanding the balance and interconnectedness of life. Let's take a moment to add to our list of the levels of organization. Here, we're focusing on understanding how biological structures are organized, from the simplest to the most complex. This slide introduces the concept of levels of organization, which is fundamental to grasping how living things are put together. As we go through this, keep in mind that these levels build on each other, creating the complex systems that sustain life. Recognizing these levels helps us see the big picture, how tiny cells come together to form tissues, organs, and ultimately entire organisms. This interconnected hierarchy is crucial for understanding biology as a whole and connects to our overall theme of exploring life's complexity. So, as we move forward, remember that each level plays a vital role in maintaining the stability and functionality of living organisms. So when we talk about the environment around an organism, we're referring to everything that makes up its world. This includes all the living things like plants, animals, fungi, and microorganisms, basically everything that has life. But it also includes all the non-living things, such as sunlight, water, air, soil, and temperature. Together, these make up what we call the environment. Now, within this environment, we can break it down further into two main categories: biotic factors and abiotic factors. Biotic factors are all the living components, those creatures and plants that interact with each other. Abiotic factors, on the other hand, are the non-living parts, like climate, temperature, and nutrients in the soil. Both are crucial because they influence how organisms survive, grow, and reproduce. Understanding the environment is key because it shapes the way living things behave and adapt. It's the foundation for everything we're discussing in this presentation, how organisms interact with their surroundings and with each other. So, recognizing the balance and interplay between biotic and abiotic factors helps us better understand ecosystems as a whole. Let's take a closer look at the factors that influence an ecosystem. First, we have abiotic factors, which are non-living elements like sunlight, temperature, water, and soil. These abiotic factors set the stage for what kind of life can thrive in a particular environment. They influence everything from plant growth to animal survival. Next, we have biotic factors, which are the living components of an ecosystem. This includes plants, animals, bacteria, fungi, basically all living things that interact and affect each other within that environment. Understanding the balance between abiotic and biotic factors is key to grasping how ecosystems function and how they maintain stability. Connecting this to our overall theme, recognizing these influences helps us see how ecosystems are complex systems with interconnected parts. Both non-living and living factors work together to shape the health and dynamics of an environment. Ecology is essentially the scientific study of how different organisms interact with each other and with their environment or surroundings. It's about understanding the relationships that shape life on Earth. When we talk about interactions between organisms, we're referring to things like predator and prey relationships, competition for resources, or symbiotic partnerships. But ecology doesn't stop there. It also looks at how these organisms influence their environment, whether it's a forest, a pond, or even a city ecosystem. This field is crucial because it helps us see the bigger picture of how life systems work together. Everything is interconnected, and understanding these interactions allows us to better protect our environment and manage natural resources responsibly. It ties into the overall theme of our presentation by highlighting the importance of balance and interconnectedness in the natural world. The fundamental idea behind the study of ecology is that all organisms are interdependent. This means that every living thing relies on others in some way, whether directly or indirectly. They don't exist in isolation. Instead, they are part of a complex web of relationships. These organisms constantly interact with one another, like animals competing for resources, plants providing shelter, or predators and prey maintaining balance. But it's not just about living things interacting. Organisms also interact with the physical environment around them. They depend on factors like water, soil, temperature, and sunlight to survive and thrive. Understanding this interconnectedness helps us see how ecosystems function as a whole. It highlights the importance of each component, no matter how small, because everything is linked together. This idea is core to ecology and helps us appreciate the delicate balance that sustains life on Earth. All right, let's take a closer look at what basic requirements are essential for survival. When we talk about survival needs, the key elements are food, water, and shelter. These are the fundamental things that all organisms, including humans, require to stay alive. Food provides the energy and nutrients necessary for growth and maintenance. Without it, our bodies can't function properly. Water is equally vital because it keeps us hydrated, helps regulate temperature, and allows our cells to work efficiently. Shelter might seem simple, but it plays a crucial role in protecting us from the elements and providing a safe environment. So, when we ask what do organisms need to survive, these are the core needs that come to mind. They form the foundation of life, and understanding these needs helps us see how different organisms adapt to their environments to meet them. This connection between basic survival requirements and adaptation is a key part of the overall theme of how life persists and thrives in diverse conditions. Let's take a closer look at which organisms are heterotrophic and which are autotrophic. First, when we say autotrophic, we're talking about organisms that can produce their own food, typically through processes like photosynthesis. These are often plants, algae, and certain bacteria that harness sunlight or inorganic substances to create energy-rich compounds. On the other hand, heterotrophic organisms cannot make their own food. Instead, they rely on consuming other organisms or organic matter for energy. This group includes animals, fungi, and many bacteria. Understanding these differences is fundamental because it ties directly into how organisms obtain nutrients and sustain themselves in various environments. Recognizing whether an organism is autotrophic or heterotrophic helps us comprehend ecological interactions, food chains, and energy flow within ecosystems. So, as we review these types of nutrition, keep in mind that this distinction is at the heart of many biological processes and the overall balance of life on Earth. All right, let's look at how populations are labeled by the function they serve in the ecosystem. We can see three main categories here: producers, consumers, and decomposers. Producers are the organisms, like plants and algae, that make their own food through photosynthesis. They form the base of the food chain and provide energy for all the other organisms. Consumers are the organisms that rely on others for their energy. They include herbivores, which eat plants, and carnivores or omnivores, which eat other animals. Decomposers play a vital role too. They break down dead organic material, recycling nutrients back into the environment, which supports the growth of producers. These categories help us understand the different roles populations play within the ecosystem, and recognizing these functions is key to seeing how energy flows and nutrients cycle through the system. It's all interconnected, and each group has a unique and essential part to play in maintaining ecological balance. Sunlight is the main energy source for life on Earth. It provides the energy that powers most of the processes we see in nature. These organisms that capture sunlight and turn it into food are called autotrophs. Autotrophs use light energy or chemical energy to make their own food, which is a crucial part of the food chain. When we think of these producers, plants are the most obvious example. But it's not just plants. There are also plant-like protists, such as algae and certain bacteria that are also producers. These producers form the foundation of most ecosystems because they create the food energy that supports other organisms. So, in essence, they are the primary source of energy for life on Earth, connecting directly to the overall theme of how energy flows through living systems. Let's talk about light energy and how it powers different processes in nature. First, we have chemosynthesis, which is a fascinating process performed by bacteria. These bacteria use chemical energy rather than light to produce carbohydrates. It's like they have their own way of generating food, using chemicals from their environment. The general reaction involves oxygen and glucose, represented as 6O2 plus C6H12O6. Remember, this process is crucial in environments where sunlight doesn't reach, like deep-sea vents. Next, we have photosynthesis, which is probably more familiar. This process uses light energy, sunlight, to convert carbon dioxide and water into oxygen and carbohydrates. So, in a way, plants and algae are the Earth's solar panels, capturing light and transforming it into the food that fuels almost all life on our planet. Both chemosynthesis and photosynthesis highlight how vital energy conversion is to sustaining life, whether through chemical or light energy. These processes connect directly to our overall theme of how organisms harness energy to survive and thrive. Let's talk about consumers. Consumers are organisms that rely on other organisms for their energy and food supply. Essentially, they don't produce their own food like plants do. Instead, they depend on eating other organisms. You might also hear them called heterotrophs, which is a term that highlights their dependency on consuming other life forms. This concept is crucial because it shows how energy flows through an ecosystem, with consumers playing a vital role in maintaining the balance. Understanding consumers helps us see how interconnected life is and how energy moves from producers to various levels of consumers. This ties into the bigger picture of ecological relationships and the flow of energy that sustains all living things. Let's take a closer look at two main types of animals based on their diets. Carnivores are animals that eat only other animals. They rely on meat for their energy, which is a key part of their diet. On the other hand, herbivores obtain their energy by eating only plants. This distinction is important because it influences their behavior, anatomy, and even their role in the ecosystem. Understanding these dietary differences helps us see how animals are adapted to their environments and how they fit into the larger food web. It's fascinating to see how these feeding strategies shape the way animals live and interact with their surroundings. Let's talk about decomposers first. These are the organisms that break down dead organic matter, like fallen leaves, dead animals, and other waste. They play a crucial role in ecosystems because they recycle nutrients back into the soil, which helps plants grow and keeps the environment healthy. Without decomposers, dead material would accumulate, and nutrients wouldn't be available for other organisms. Now, moving on to omnivores. These creatures have a very versatile diet. They eat both plants and animals. This means they can adapt to different food sources depending on availability, which often gives them an advantage in various environments. Think of animals like bears or humans. They're great examples of omnivores because their diet isn't limited to just one type of food. Connecting these points to the bigger picture, both decomposers and omnivores are vital for maintaining balance in ecosystems. Decomposers ensure nutrients are recycled, supporting plant life, while omnivores help control populations and utilize a wide range of food sources. Together, they contribute to the overall health and stability of ecological systems. Energy flows through an ecosystem in a single direction. It starts with the sun or inorganic compounds, which provide the energy source. From there, it moves to autotrophs, also known as producers, which are capable of photosynthesis or chemosynthesis. These organisms convert inorganic material into organic matter. Then, the energy continues to pass on to heterotrophs, or consumers, which rely on other organisms for their energy. This unidirectional flow of energy is a fundamental concept that helps us understand how ecosystems function and how energy sustains all living things within them. Let's take a look at the food chain, which is essentially a series of steps where organisms transfer energy through eating and being eaten. The arrows in this diagram show us the direction in which energy flows from one organism to the next. We start with the producer, like grass, which makes its own food through photosynthesis. Then, energy moves to the herbivore or primary consumer, such as a cricket that eats the grass. Next, a predator like a frog might eat the cricket. Finally, the energy reaches the top consumer or carnivore, like a raccoon. This sequence highlights how energy moves through an ecosystem, starting from the base with producers and ending with the top predators. Understanding this flow helps us see how interconnected and dependent different organisms are within a food chain, which ties into the bigger picture of energy transfer and ecosystem balance. A food chain illustrates a one-way flow of energy within an ecosystem. It shows how energy passes from one organism to another in a specific sequence. However, it's important to remember that a food chain isn't the only way energy moves through an ecosystem. There are other complex interactions and pathways. So you might ask, what exactly is a food chain? Well, it's a simple model that helps us understand the transfer of energy from producers, like plants, to consumers, such as herbivores and carnivores. Recognizing this flow is key to understanding how ecosystems function and stay balanced. Let's take a closer look at this food web. Starting with the grass at the bottom, this is our producer. Producers are the organisms that create their own food through photosynthesis, and in this case, the grass is converting sunlight into energy that supports the rest of the ecosystem. Now, among the animals listed, mice, raccoons, weasels, and hawks, who do you think is the top consumer? The answer is the hawk. The hawk is at the top of this food chain because it preys on the other animals but isn't typically preyed upon itself. This slide introduces the concept of a food web, which is a network of interconnected food chains within an ecosystem. Unlike a simple chain, a food web shows how different organisms are linked through various feeding relationships, highlighting the complexity and interdependence of living things in a healthy ecosystem. Understanding these connections helps us see how energy flows from producers to consumers and how changes at one level can impact the entire system. It's a great way to visualize the balance that keeps ecosystems functioning. Now, let's explore the different trophic levels, which are essentially the steps in a food chain or food web. Starting at the bottom, we have level 1, producers, also known as autotrophs. These are organisms like plants and algae that can make their own food through photosynthesis. They're the foundation of most ecosystems because they provide energy for all the other levels. Moving up, we have level 2, primary consumers, or herbivores. These are the animals that eat the producers. Think of insects munching on leaves or deer grazing on grass. They directly depend on the producers for their energy. Next, at level 3, are the secondary consumers. These are carnivores or omnivores that eat the primary consumers. For example, a fox that hunts rabbits or a bird that feeds on insects. They play a crucial role in controlling the populations of herbivores. Finally, at level 4, we find the tertiary consumers, which are usually top carnivores. These are predators that sit at the top of the food chain, like wolves or big cats. They typically have no natural predators themselves and help maintain the balance in the ecosystem. Understanding these levels helps us see how energy flows through an ecosystem, highlighting the interconnectedness of all living things and emphasizing the importance of each level in maintaining ecological stability. Let's take a closer look at ecological pyramids. This diagram illustrates the relative amount of energy or organisms contained within each trophic level of a food chain or web. Essentially, it helps us visualize how energy flows and how populations are distributed across different levels. The key point here is that, as you move up the food chain, the amount of energy decreases. This is because energy is lost at each step, mainly as heat. Similarly, the number of organisms tends to decrease at higher levels. Understanding this pyramid structure is crucial for grasping how ecosystems are balanced and how energy transfer impacts biodiversity. It ties directly into our overall discussion of how organisms interact and survive within their environments. Let's take a look at the energy pyramid. This diagram shows us the relative amount of energy available at each trophic level. Organisms in a given level use the energy they have for essential life processes like growth, photosynthesis, cellular respiration, and metabolism. As they do this, they also release some energy as heat. Remember, every chemical process in our bodies, like burning calories, releases heat as a byproduct. Here's an important rule to keep in mind, the rule of 10. It tells us that only about 10% of the energy at one trophic level actually makes it to the next level above. So, energy decreases as you go higher up the pyramid. Now, connected to this idea is the biomass pyramid. This shows us the amount of living organic matter at each trophic level. Essentially, it gives us a visual of how much living material exists at each step in the food chain. Both the energy pyramid and the biomass pyramid help us understand how energy and matter flow through ecosystems, which is key to grasping the bigger picture of ecological relationships. All right, let's take a closer look at these numbers. When we talk about the biomass pyramid, we see that it starts with about 0.1% at the top, which might seem tiny, but it makes sense given the energy transfer in ecosystems. Moving down, about 1% of the biomass is present at the next level, and then around 10% at the next. Finally, at the base, we have 100%, representing the total biomass of the producers, like plants and algae. This illustrates how energy and biomass decrease as we go up the pyramid, which is a key concept in understanding ecosystem dynamics. The biomass pyramid helps us visualize the distribution of living material at each level, and it highlights why the largest biomass is usually at the bottom, supporting everything above. It's a great way to connect energy flow to the overall health and structure of ecosystems. Let's take a closer look at the energy and biomass pyramid. This slide illustrates how energy flows through an ecosystem and how living tissue is distributed across different trophic levels. As you can see, both the amount of energy available and the amount of living tissue decrease as we move higher up the pyramid. This is a key concept because it explains why there are usually fewer top predators compared to producers at the bottom. The energy that's captured by plants or other primary producers is gradually lost at each level, mostly through metabolic processes like movement and heat loss. Similarly, the biomass, meaning the total mass of living organisms, also diminishes higher up the pyramid. This pattern reflects the efficiency of energy transfer in ecosystems and highlights the importance of primary producers and the energy they provide as the foundation of the food chain. Understanding this helps us grasp the overall dynamics of energy flow and the structure of ecosystems. As we look at this energy pyramid, it's important to understand that there is more energy available at the bottom, which is where the producers, like plants, are located. Because of this, we also see that there are more organisms at the bottom of the pyramid. Think of all the plants and small creatures that make up the base. As we move up to the top of the pyramid, the amount of energy decreases. There's less energy available for the top predators. Correspondingly, there are fewer organisms at the top because they rely on the energy that's been transferred up from the bottom. An essential point to remember is that energy is lost as we go up the pyramid. Most of this loss occurs as heat. This is why energy pyramids are typically shaped with a broad base and a narrower top. Understanding this flow of energy helps us grasp how ecosystems are structured and why energy transfer efficiency is so important in maintaining the balance of life within them. So, who is ultimately responsible for the recycling of nutrients in our ecosystems? The answer is decomposers. These organisms, like bacteria and fungi, play a crucial role in breaking down dead organic matter. They essentially act as nature's recyclers, ensuring that vital nutrients are returned to the soil and made available for new plant growth. Now, what exactly gets recycled through this process? Primarily, minerals and nutrients. Minerals are inorganic elements that plants need to grow, such as phosphorus and potassium. Nutrients include a broader range of elements that plants absorb from the soil, like nitrogen. This entire process of breaking down dead matter and recycling these essential components is what we call recycling. It's a continuous, vital cycle that maintains the health and balance of ecosystems. By understanding this, we see how critical decomposers are. They keep the nutrient cycle moving smoothly, supporting plant life and ultimately the entire food chain. This concept ties back to our overall theme of ecosystem sustainability and the importance of maintaining natural processes. So what else gets recycled in our environment? Well, besides the things we usually think of, like plastics and paper, there are some crucial natural cycles at work. For example, carbon dioxide is constantly being recycled through processes like photosynthesis and respiration. Water also goes through a continuous cycle, evaporating, condensing, and precipitating, keeping our freshwater supplies in balance. Carbon, too, is recycled, primarily through the carbon cycle, which links the atmosphere, oceans, and land. And all of these processes are driven by the energy from the sun, which keeps this entire cycle going. Recycling isn't just about waste management. It's a fundamental part of how nature sustains itself and maintains balance. This interconnected recycling system is essential for supporting life on Earth, and understanding it helps us appreciate the importance of preserving these natural cycles. Let's take a closer look at the relationships between the different components of the environment and the ecosystem. As we know, an ecosystem is made up of various parts that interact and depend on each other. These components include the biotic factors, like plants, animals, and microorganisms, and the abiotic factors, such as air, water, soil, and sunlight. The key point here is that these components are interconnected, forming a complex web of relationships. For example, plants rely on sunlight, water, and nutrients from the soil to grow, while animals depend on plants for food and shelter. In turn, animals produce waste that enriches the soil, supporting plant growth. This cycle of interactions highlights how changes in one component can influence the entire ecosystem. Understanding these relationships helps us see the environment as a dynamic system, where each part plays a crucial role in maintaining balance. When we consider human activities, like pollution or deforestation, we see how disrupting one component can have ripple effects across the ecosystem. So, ultimately, recognizing the relationships between these components emphasizes the importance of preserving the integrity of the entire system. It reminds us that our actions can impact not just one part, but the entire web of life. This interconnectedness is at the heart of understanding how ecosystems function and why they need our careful stewardship. Let's talk about competition, which occurs when two organisms, whether they are of the same species or different ones, try to use the same ecological resource at the same time and in the same place. Think of resources like food, water, or shelter. These are essential for survival, and when they are limited, competition naturally arises. This type of interaction is a key part of ecological relationships because it influences how populations grow and how different species coexist in an ecosystem. It's important to understand that competition can shape behaviors and adaptations over time, helping organisms find ways to survive despite these challenges. So, in essence, competition is all about the struggle for resources that are vital for life, and it plays a crucial role in the dynamics of ecosystems and the relationships between organisms. Rams compete with each other for mates, which is a clear example of how animals often have to fight for reproductive success. This competition helps ensure that the strongest or most fit rams pass on their genes. Similarly, monkeys also compete, not just with each other, but with other animals, for food. This shows how competition is a common theme across different species and plays a crucial role in survival and reproduction. These behaviors highlight the importance of competition in natural selection, as animals constantly adapt to outcompete rivals and secure resources essential for their survival and future generations. It's a fascinating part of how life on Earth maintains its diversity and resilience. Today, we're going to talk about predation, which is a key interaction in ecosystems where one organism captures and feeds on another. When we think about predation, it's important to understand the roles involved. The predator is the organism that does the killing, actively hunting or capturing its prey. The prey, on the other hand, is the organism that becomes food for the predator. Recognizing these roles helps us understand the dynamics of food webs and how energy flows through different ecosystems. Predation is a fundamental concept because it influences population sizes, community structure, and even the evolution of species. By studying these interactions, we gain insight into the balance of nature and the interconnectedness of all living things. Let's talk about mutualism, which is a type of relationship where both species benefit, what we call a win-win situation. For example, insects and flowers have a mutualistic relationship. The insects get food from the flowers, like nectar, while the flowers benefit because the insects help pollinate them. Can you think of any other examples of mutualism? Now, moving on to symbiosis. This is a broader term that describes any relationship where two species live very closely together. Mutualism is a type of symbiosis, but not all symbiotic relationships are mutualistic. Some might benefit one species without helping or even harming the other. Understanding these relationships is key to grasping how different species interact within ecosystems and contribute to their stability. Let's take a closer look at an example of commensalism, barnacles on a whale. In this relationship, the barnacles benefit by attaching themselves to the whale's skin, which helps them access food sources like plankton more easily. The key point here is that the whale, in this case, is neither helped nor harmed by the barnacles. This is what we call commensalism, where one species benefits and the other remains unaffected. Understanding these types of relationships helps us see how different organisms interact within ecosystems, often in very specialized ways. It's a fascinating example of how some species coexist without directly impacting each other's survival. Let's take a look at commensalism, which is a fascinating type of symbiotic relationship. For example, birds often build their nests in trees. This benefits the birds by providing a safe place to raise their young, while the tree itself isn't really affected. It's just hosting the nest. Another great example is the remora fish. It attaches itself to a shark and gets a free ride through the water. The shark doesn't mind because the remora isn't harming it. These examples highlight how one species benefits without causing harm to the other. Understanding commensalism helps us see how different organisms coexist in nature, often relying on each other in subtle but important ways. Parasitism is a type of symbiotic relationship where one organism, called the parasite, lives on or inside another organism, which we call the host. The key point here is that the parasite benefits, but the host is harmed in the process. The parasite derives some or all of its nutritional needs from the host, which makes this relationship a win-lose situation. The parasite gains nourishment and survival advantages, while the host suffers from the harm caused. For example, think about fleas on a dog. Those fleas feed on the dog's blood, harming the animal and causing discomfort. This example highlights how parasitism is all about that delicate balance where one benefits at the expense of the other, fitting into our overall theme of interactions within ecosystems. Now let's take a closer look at parasitism, one of the fascinating interactions in the natural world. For example, sea lampreys feed on the fluids of other fish. They attach themselves and extract blood and body fluids, which can really harm their hosts. This is a clear example of parasitism, where one organism benefits at the expense of another. Similarly, we see a mosquito biting a human to extract blood, which it needs for reproduction. The mosquito benefits, but the human might experience discomfort or even disease transmission. Another example is wasp eggs laid on the back of a caterpillar. The wasp larvae develop by feeding on the host, often weakening or killing it. Overall, parasitism is a natural strategy where parasites gain nutrients or resources, often harming their hosts. It's a key concept that helps us understand the complex interactions and balance within ecosystems. So, let's take a closer look at these different types of relationships: mutualism, commensalism, and parasitism. These interactions are key to understanding how species coexist and influence each other in ecosystems. Mutualism is when both species benefit from the relationship, like bees pollinating flowers. Both gain. Commensalism, on the other hand, is when one species benefits and the other is unaffected, such as barnacles attaching to whales. They thrive, but the whale doesn't mind. Lastly, parasitism is when one species benefits at the expense of the other, like ticks feeding on a host, which can cause harm. Recognizing these relationships helps us understand the complexity of ecological interactions and their impact on biodiversity. Throughout this presentation, we've seen how these interactions shape ecosystems and influence species survival. So, identifying whether a relationship is mutualistic, commensal, or parasitic is fundamental to understanding ecological balance. Let's take a closer look at some of the key elements involved in biogeochemical cycles. Water, of course, is fundamental. It's essential for all forms of life, and its cycle involves processes like evaporation, condensation, and precipitation, which help distribute nutrients across the planet. Then we have nitrogen, which is vital for amino acids and proteins. The nitrogen cycle involves processes like fixation, nitrification, and denitrification, ensuring nitrogen is available in forms that organisms can use. Next is carbon dioxide, a critical component for photosynthesis and a major greenhouse gas. Its cycle connects the atmosphere, oceans, and land through processes like respiration, decomposition, and carbon sequestration. Phosphorus is another key element, mainly cycling through rocks and soils, supporting DNA, bones, and energy transfer within cells. Sulfur, although less discussed, is equally important. It's involved in amino acids and enzymes, cycling through sulfur compounds in the environment. All of these elements are interconnected through biogeochemical cycles, which are essential for maintaining the balance of ecosystems. Understanding these cycles helps us grasp how nutrients move and transform within the environment, ultimately supporting life on Earth. This interconnectedness highlights the importance of conserving these natural processes as part of our broader environmental stewardship. Chemical elements are essential for life, and they come from both living organisms and the non-living environment around us. These elements don't just stay put, they cycle through the Earth in different ways. Some cycle through the atmosphere, which we call the gas cycle. In this cycle, elements like carbon and nitrogen move through the air, the main reservoirs being the atmosphere itself and the oceans. On the other hand, some elements follow a sedimentary cycle, moving from land to water and then settling into sediments. This process often involves elements like phosphorus and sulfur, which are stored in soils, waters, and sediments for long periods. All of this cycling is part of what we call biogeochemical cycles, the movement of these elements through biological, geological, and chemical processes. Understanding these cycles helps us see how interconnected our environment truly is and how vital these processes are for sustaining life on Earth. So, what are the two main processes in the carbon cycle? Well, first, we have photosynthesis. This is where plants, algae, and some bacteria take in carbon dioxide from the atmosphere and convert it into organic matter, like sugars, using sunlight. It's a crucial process because it removes CO2 from the air and stores it in living organisms. The second process is respiration. This is how plants, animals, and microbes break down organic carbon compounds to release energy. During respiration, carbon stored in organisms is converted back into carbon dioxide, which then returns to the atmosphere. Together, these two processes, photosynthesis and respiration, form a continuous cycle that regulates carbon levels in the environment. They are fundamental to maintaining the balance of carbon in our atmosphere and biosphere, which ties directly into our overall discussion about climate change and the importance of understanding natural processes. So, during photosynthesis, carbon enters the biosphere in the form of carbon dioxide, or CO2. This process involves CO2 combining with water, H2O, to produce glucose, which is C6H12O6, along with oxygen, O2, and water again. This is how plants and other photosynthetic organisms take in carbon and convert it into organic molecules that support life. Then, in cellular respiration, the process reverses. Organisms take in oxygen and use it to break down the glucose they've produced, releasing CO2 back into the environment. This reaction also produces water and energy, which powers most of the activities in living organisms. This cycle of carbon moving between the atmosphere, biosphere, and other parts of Earth is fundamental to maintaining the balance of life and supporting ecosystems. It illustrates how interconnected life processes are and how vital carbon cycling is for sustaining life on our planet. Today, I want to talk about the nitrogen cycle, which is a fundamental process in our ecosystem. The nitrogen cycle describes how nitrogen moves through the environment, living organisms, and the atmosphere. It's crucial because nitrogen is a key component of amino acids and proteins, essential for all living things. The cycle begins with nitrogen fixation, where certain bacteria convert atmospheric nitrogen, N2, into forms that plants can absorb, like ammonium. This is a vital step because most organisms can't use nitrogen gas directly. Then, through nitrification, Other bacteria convert ammonium into nitrites and then nitrates, which plants readily take up as nutrients. Next, we have assimilation, where plants absorb these nitrates and incorporate them into their tissues. When animals eat these plants, they also assimilate nitrogen into their bodies. But not all nitrogen stays in the plant or animal. Some of it returns to the soil through waste products and decomposition. This process is called aminification, producing ammonium again. Then, nitrifying bacteria continue to convert ammonium back into nitrates, maintaining the cycle. Finally, denitrification occurs when bacteria convert nitrates back into nitrogen gas, releasing it into the atmosphere and completing the cycle. Understanding this cycle emphasizes how interconnected our environment is, and it highlights the importance of maintaining healthy soil and ecosystem functions. It ties back to the overall theme of sustainability and the delicate balance required to keep our ecosystems thriving. Let's talk about nitrogen, or N, which is actually a key component of many essential molecules in plants and animals. It's found in proteins, which are the building blocks of life, as well as in DNA and RNA, the molecules that carry genetic information. Nitrogen is also a vital part of chlorophyll, the pigment that allows plants to photosynthesize. Interestingly, nitrogen makes up the largest portion of our atmosphere. About 78% of the air we breathe is nitrogen gas. But here's the catch. Despite its abundance in the atmosphere, plants and most organisms can't use nitrogen in its gas form directly. They need it in a different form, which means nitrogen has to be fixed or converted into a usable form, like ammonium or nitrate, so that it can be absorbed and utilized. This process of nitrogen fixation is crucial because it bridges the gap between the plentiful atmospheric nitrogen and the nitrogen compounds that living organisms need to grow and thrive. So, understanding how nitrogen is transformed and made accessible is fundamental to grasping the bigger picture of nutrient cycling and ecosystem health. Now, let's take a closer look at the oxygen cycle, specifically through the process of photosynthesis. Photosynthesis is crucial because it's how plants and other photosynthetic organisms convert carbon dioxide and water into glucose and oxygen, using sunlight as energy. This process is essential for maintaining the oxygen levels in our atmosphere, which supports most life forms on Earth. As plants take in carbon dioxide, they release oxygen back into the air, a vital exchange for sustaining life. This cycle highlights how interconnected all living things are, with plants acting as the Earth's natural air purifiers. Understanding this process helps us appreciate the delicate balance of our ecosystem and the importance of conserving plant life. It's a perfect example of how biological processes support the overall health of our planet. Let's talk about the sources of oxygen in our environment. Primarily, oxygen is produced through processes like photosynthesis and respiration. During photosynthesis, plants and certain microorganisms convert carbon dioxide and water into oxygen and glucose using sunlight. Respiration, on the other hand, releases oxygen back into the atmosphere as organisms break down organic materials for energy. Another interesting process is the photodissociation of water vapor, where sunlight breaks down water molecules in the atmosphere, releasing oxygen. It's also important to note that CO2 and O2 circulate freely throughout the biosphere, moving through various ecosystems and influencing climate and life processes. Some of the CO2 doesn't stay free. It reacts with calcium to form carbonates, which are part of the geological carbon cycle, helping to lock carbon away in rocks. Similarly, O2 reacts with nitrogen compounds to produce nitrates, which are essential nutrients for plant growth and are part of the nitrogen cycle. Oxygen also reacts with iron compounds to create ferric oxides, contributing to soil and mineral formation. In the atmosphere, O2 in the troposphere can be reduced to ozone, O3, which plays a role in protecting us from ultraviolet radiation. However, ground-level ozone, or ozone near the surface, acts as a pollutant. It can cause serious damage to our lungs and respiratory health. So, understanding these processes helps us see how vital oxygen is, not just for life, but also for maintaining the balance of our planet's atmosphere. Let's take a closer look at the phosphorus cycle. Phosphorus is a vital nutrient for all living organisms, primarily because it's a key component of DNA, RNA, ATP, and our bones and teeth. Unlike other element cycles, the phosphorus cycle doesn't involve a gaseous phase. It mainly moves through rocks, soil, water, and living organisms. Phosphorus starts in rocks, where it exists as phosphate minerals. Over time, through weathering and erosion, these rocks release phosphate ions into the soil and water. Plants then absorb these phosphates, which are passed along the food chain as animals eat plants and vice versa. When organisms die or excrete waste, the phosphates return to the soil or water, completing the cycle. A critical point to remember is that human activity, like mining and the use of phosphate fertilizers, accelerates this cycle, sometimes leading to environmental issues like water pollution and eutrophication. This cycle is essential not only for maintaining ecosystem health, but also for supporting agriculture and food production. Connecting this to our broader theme, understanding the phosphorus cycle helps us appreciate how nutrient cycles sustain life and how human actions can disrupt these natural processes, emphasizing the importance of sustainable practices. Let's talk about the phosphorus cycle and how it fits into the broader sedimentary cycles. As you can see, phosphorus is a key component of DNA, RNA, ATP, proteins, and enzymes, basically essential for life. This cycle illustrates how a mineral element moves through the environment and becomes part of living organisms. The primary source of phosphorus is rock, which contains phosphate minerals. Over time, erosion or mining releases this phosphorus into the environment. Once in the soil or water, phosphorus is soluble as phosphate, which is PO4. This solubility allows plants to absorb it through their roots. From there, phosphorus moves up the food chain. Plants are eaten by herbivores, which are then consumed by carnivores, and so on. Eventually, phosphorus is returned to sediment, completing the cycle. Understanding this cycle highlights how essential nutrients are recycled and how geological processes like erosion contribute to the availability of vital elements like phosphorus for living organisms. It really underscores the interconnectedness of Earth systems and the importance of nutrient cycling in sustaining life. Today, let's take a closer look at the sulfur cycle. Sulfur is an essential element for life, and it moves through the environment in a fascinating series of processes. Unlike some other cycles, sulfur can exist in various forms, gaseous, solid, and dissolved in water, which makes its cycle quite complex. One key point is that sulfur primarily moves through the atmosphere, the land, and water systems. Volcanic eruptions release sulfur gases into the atmosphere, which can then be converted into sulfates and fall back to the earth as acid rain. Additionally, sulfur is absorbed by plants and microorganisms, playing a vital role in biological systems. When these organisms die or excrete waste, sulfur can return to the soil or water, continuing the cycle. Understanding the sulfur cycle is important because it impacts everything from climate regulation to the health of ecosystems. It also connects to the broader theme of nutrient cycles and their influence on environmental stability. So, in essence, the sulfur cycle demonstrates how essential elements are continually recycled, maintaining balance in our planet's ecosystems. Let's talk about the component of protein and the sulfur cycle. Sulfur plays a crucial role in both gas and sedimentary cycles, highlighting its importance in Earth systems. The primary source of sulfur is the lithosphere, which is essentially the Earth's crust. Sulfur enters the atmosphere mainly as hydrogen sulfide, or H2S, during processes like fossil fuel combustion, volcanic eruptions, gas exchange at ocean surfaces, and decomposition of organic matter. Once in the atmosphere, sulfur compounds like SO2 and water vapor react to form sulfuric acid, or H2SO4, which is actually a weak acid. This acid is then carried back to Earth's surface through rainfall, completing part of the cycle. When sulfur in soluble forms is absorbed by plant roots, It becomes part of amino acids such as cysteine, which are essential for protein synthesis. From there, sulfur moves through the food chain as plants are eaten by animals, and eventually, when organisms decompose, sulfur is released back into the environment. This cycle underscores the interconnectedness of Earth systems and how essential sulfur is for life processes, especially in protein formation. Understanding this cycle helps us grasp how elements like sulfur are recycled in nature and their significance in maintaining ecological balance. Let's take a closer look at the building blocks of life: water, nitrogen, carbon dioxide, phosphorus, and sulfur. These elements are essential for all living organisms and form the foundation of life on Earth. Now, these elements don't stay in one place. Instead, they continually cycle through Earth systems. They move through the atmosphere, the hydrosphere, our oceans, lakes, and rivers, the biosphere, which includes all living things, and the lithosphere or Earth's crust. These cycles happen over a wide range of time scales, from just a few days to millions of years. It's a dynamic process, constantly moving and transforming these elements. And these processes are called biogeochemical cycles because they involve biological, geological, and chemical processes working together. For example, plants take up nutrients from the soil, animals consume them, and then these elements are returned to the environment through decay or other processes. Understanding these cycles helps us see how interconnected Earth systems are and highlights the importance of maintaining balance for life to thrive. It's a key part of the overall picture of Earth's sustainability and the delicate balance that supports life on our planet. This slide doesn't contain enough information. That's why we're moving to the next slide.